This part is extra. If you don't want to go through it, you don't have to. It'll just give you a better understanding of how to get the difference in potential between two very close points. So let's start by point A, which has coordinates x, y, and z, and then I just move in the x direction an amount dx. So I arrive at point C, which has coordinates x plus dx and y and z. If I get, what is partial v by partial x? Don't you remember that that's just the potential at point C minus the potential at point A divided by delta x? So that means that partial v by partial x times delta x or dx is just the difference in potential between these 2 points. So in other words, the difference in potential between these two nearby points, only moving in the x direction, is partial v by partial x dx. What if you go from point C to point D, and in doing so you're only moving in the y direction an amount dy, so you're keeping x constant and you're keeping z constant, but you're only changing y. Y goes from y to y plus dy. And if you get the potential here at D minus the potential at A, isn't that just partial v by partial y dy? And now if you go from point D to point B, in doing so, you're only changing the z coordinate by an amount dz. You're keeping x the same, you're keeping y the same, but you're only changing z from z to z plus dz. If you get the potential at B here, minus the potential at D here, what is this difference equal to? Isn't it equal to the partial derivative of potential with respect to z times dz? So now let's take these differences that we got and add them. Add all these things together. Well, this is exactly the same as this. This is the same point. We're getting the potential at the final point minus this point, and then this point minus that point, and then that same point minus this point. So the ones in blue are the same, the potential at the same point. The ones in orange are the potential at the same point. So you have here minus something plus the same thing. They cancel. Minus something plus something, they cancel. So the sum of the left-hand side terms is the potential at the final point minus the potential at the very initial point. And then when you add these, you get that. So that proves what we wanted to prove in the beginning, that the difference in potential between 2 points that are very, very close, dx and dy and dz are very small, almost approaching zero, the difference in potential is just partial v by partial x dx plus partial v by partial y dy plus partial v by partial z dz. And so that gets us to this result that we just gave without proof in the previous file. So here, if you want to understand it in a bit more detail, this video should give you that idea.